Hey guys, I'm Jade. Today is my LeetCode review vlog on the 138th problem. Copy list with random pointer. A linked list of length n is given such that each node contains an additional random pointer, which could point to any node in the list or null. We have to construct a deep copy of the list. The deep copy should consist of exactly n brand new nodes, where each new node has its value set to the value of its corresponding original node. Both the next and random pointer of the new nodes should point to new nodes in the copy list, such that the pointers in the original list and the copy list represent the same list state. None of the pointers in the new list should point to nodes in the original list. We have to return the height of the copied linked list. Let's see example 3 here to understand it easily. We got 3 nodes. The first is 3, and the random node points to null. And the second node, its value is 3, 2, and the random node points to the first node. And for the third node, 3, and its random node also points to null. And the output is exactly the height of the copy linked list, and each value of the current node and next node and random node are the same by the copied version. Then let's get started with the intuition to solve the problem. So the keyword of the intuition is to passes and hash map. And the detail consists of 3 steps. The first step will traverse the original linked list. And for each node we meet, we'll create a new node with the same value. And we also create a hash map and create each entries have mapping rules between the original nodes and their corresponding copies using a hash map. So the first step is traverse the original linked list and save the mapping rules to the hash map. And the second step is we have to update the new pointer and random pointer for the new copied linked list. Update next and random pointer for the copied linked list. And the detail is after completing the first pass, we'll traverse the original linked list again. And for each node, we'll set the next pointer and the random pointer of each copy node by looking up in the hash map. By search the original node, then we can get the next node. We can get the copy node. In the final step, we just return the height of the copy list. Then let's get started with the code to solve the problem. So the very first step is we have to check the edge cases. If height equals null, we just return null. And the second step, we'll create a hash map to store the mapping rules between the original nodes and the new nodes. Let's say hash map of node and node. Let's call it map equals new hash map. Then we have to do the first pass with a while loop. And inside the while loop, we'll create new nodes and store them in the map. While before that, we have to create a variable to help us to determine where this is the end of the while loop. Same node, current variable, started at height. And the condition of the while loop is while current pointer not equal to null, then we'll continue the loop. And inside the while loop, the first state, we have to map the original node to the new node. Let's say map put current pointer in the new node. And the value is current.value. Next, we have to make the current pointer points to the next node for the next iteration. Current equals current.next. And this is out of code for the first pass. And out of the first pass, we have to reset the current pointer to the height again for the second pass. Current pointer equals height pointer. Then we'll start the second pass. Inside the second pass, we have to assign the next pointer and the random pointer for each new node using the hash map we created before. While current pointer is not equal to null, then we'll set the new pointer of each copy node by looking up the next node in the hash map by the original next node. First, let's say map get current dot next. Let's update the next node of the new node first. And value is map get current dot next. Then we also have to update the random pointer of each copy node. And the approach is very similar, which is map get current dot random equals map dot get of current dot random. Then we have to make the current pointer points to the next node. Current equals current dot next. And out of the second pass, we just return the height of the copied linked list. Return map.get height, because the height is the height node of the original list. So we want to get the height of the copy list from the hash map. Then let's check the correctness and analyze the time and space complexity. So the time complexity is big O of n. Yes, our code got accepted. Big O of n. This is because in the first pass, we created the new nodes and storing them in the hash map, which takes big O of n time. And in the second pass, we set the next pointer and random pointer for the new copied node. And this process also takes big O of n time. So the overall time complexity is big O of n. And the time complexity, it is also big O of n. This is because we use a hash map to store the mapping rules between the original nodes and the new nodes. And this is the end of my LeetCode review vlog on this problem. Copy list with random pointer. And I highly recommend you guys to visit my online GitHub page here. You can see all the nodes for top 150 LeetCode problems. For each problem, you can see the problem description, intuition, Java code with annotations, and different solutions. For example, the method 1 here, we can have 3 passes, but only big O of 1 time space complexity to solve the problem. And the final time and space complexity analysis. You can also visit my GitHub repository here, which contains the codes and nodes to build the online GitHub page here. And I'll put those two links on my YouTube description below. And thank you guys for watching. I'll see you next time. Bye bye.